Ripple the image. In this shader we're going to play around with which texel to select from a texture image to give the appearance of a ripple. Don't worry, it's surprisingly easy. First, let's add a new uniform. Slide down to the uniforms definition and enter uDuration value 8.0, and in the fragment shader add uniform float uDuration. Great, we're ready to update the main function. Replace the existing code with vec2p equal vposition.xy, float len equal length p, vec2ripple equal vuv plus p divided by len times 0.03 times cos len times 12.0 minus u time times 4.0. Float delta equals sine mod u time u duration times 2.0 times pi divided by u duration plus 1.0 divided by 2.0. vec2 uv equals mix ripple vuv delta. vec3 color equal texture 2d utex uv.rgb. The vec2p is set to the value vposition.xy. Then we save the length of this vector as the variable len. It's important that the center of the screen in this coordinate space is at 0, 0. We can do this using the varying vposition. That ranges from -1 to 1 for our plane geometry. Now we want to create a new UV value which we call ripple, that is the current VUV varying plus a value. Let's take a careful look at how we generate the value ripple. This is where the ripple will set the UV. By adjusting the value of UV we can grab the color of the current pixel from a different part of the texture image, a different texel. By default we grab the texel from position VUV, but if we adjust this value we can create all manner of effects. Notice that the value ripple is generated by adding p divided by len times 0.03 times cos len times 12.0 minus u time times 4.0 to the current value for VUV. P divided by len times 0.03 gives a value that radiates from the center of the screen. Imagine drawing a line from the center of the screen to the test point. The pixel that we choose to use will be somewhere on this line. So we're pulling the pixel color from somewhere on the image that is either closer to the center or further away. The direction is chosen by the value returned from the cos function. This takes the len value and multiplies it by 12. Try adjusting this value. You will see that it affects the number of ripples, while the multiple of time simply affects the speed of the ripple. Try replacing delta with 0 on this line. Now you'll see a continuous ripple effect. The delta value coupled with mix interpolates between the ripple value for UV and VUV. When delta equals 0, the mix function returns ripple. When delta equals 1.0, the mix function returns VUV. Between these values, the return value is an interpolation of these two vec2 quantities. Take a look at how we generate the delta value. We first get the remainder of the value of u time divided by u duration using the mod function. This will be a value between 0 and u duration. Remember that the sine function takes values in the range 0 to 2 pi. So we multiply this value by 2 pi divided by u duration to ensure we are in that range. The result of the sine method will be a value between -1 and 1. We add 1 to this and divide by 2 to move to 0 to 1 as the possible values. We've done this a lot in the course. Using sine in this way is very common where time is included in a shader. Now we know how to ripple a texture. This video is taken from the course Learn GLSL Shaders from Scratch. A link to the complete course is in the description below.